Okay, this is all about background radiation. Right, background radiation is radiation that exists all the time. You can't get rid of it. It's always there. It's radiation from the environment, including space or devices, things like X-ray machines. Where does background radiation come from? Well, most of it comes from the air in a form of gas called radon. Some of it comes from space, about 10% from cosmic radiation. Some from the food and drink we eat, so bananas and coffee are radioactive. And some of it is from the ground. And also there is a load that comes from medical use, things like X-rays. There's a really good video on this, by the way. A chap called Veritasium measures background radiation with bananas. Well worth watching, very interesting as well. If you want just a bit of light-hearted relief during the revision, good video to watch, about 10 minutes in length. There's a little section there about 0.5%, which comes from air travel. But if you travel in the plane, you're exposed to more radiation than normal, largely from space. So pilots and air hostesses are limited to the amount of hours they can spend in the air in a year. Nuclear reactors provide a small amount as well. Nuclear weapons from bombs dropped years and years ago, and nuclear accidents. But you can see that most of those, there's a tiny, tiny amount. I've spelled nuclear accidents wrong, by the way. A famous nuclear accident was Chernobyl. But it's a tiny, tiny amount. It's absolutely pathetic, really, the amount we get from background radiation. Right, where does radon gas come from? Well, in some parts of the world where they've got loads of granite has got uranium in it, and this uranium decays to form radon gas, and the radon gas is radioactive. It gets into people's homes, it gets trapped into cellars, and in some parts of the world, mainly like Cornwall, for example, they have to have loads of fans taking out the air from cellars to stop build-up of radon gas. It does lead to an increased risk of cancers in Cornwall. I think 1 in 5,000 people die in Cornwall each year as a result of cancer from radioactive gas. This is a typical structure of an atom. We'll go into greater depth about this later on, but just to give you a quick overview, obviously you've got in the nucleus, the bit in the middle are the protons and the neutrons, and you have electrons whizzing around it. In nuclear physics, we're not really interested in the electrons on the outside, we're interested in the protons and neutrons. And it turns out that if you have too many neutrons, or your atom or nucleus is too big, or you've got too much energy because your atom has got an odd shape, for example, then you will decay. There's a chance that it will decay. It will give out radiation, alpha, beta, or gamma, and there's a video all about that. But we don't know exactly when. It's a random event. We can't predict it. It's sort of unpredictable, but it is also predictable to a point, because we know that if you have like a million or a billion atoms, that a fraction of them are going to go after a period of time, and that's all to do with half-life. You'll see that later on. So you cannot predict any individual atom doing it, but you know that if you've got billions of atoms, that you know that roughly half of them will go, that you cannot predict any individual atom decaying at any point. And that is everything we need to know about background radiation.